Let's graph the exponential equation 2 raised to the negative x plus 3. So we'll make our little xy table. And the values we'll put in for x, well, that depends on what's here at the exponent. What would make that 0 is 0. So do some numbers a little bit smaller, negative 1 and negative 2, a little larger, 1 and 2. So first we'll put back into the original equation the negative 2. And don't forget the parentheses. So 2 raised to the negative 2 is 2 raised to the positive 2 plus 3. And 2 squared is 4 plus 3 is 7. So now we'll put into the original equation negative 1. So 2 raised to the negative 1 plus 3 is 2 raised to the positive 1 plus 3. And 2 plus 3 is 5. So now we'll put in the value 0. And the opposite of 0 is still 0. And 2 to the 0 power is 1. Plus 3 more is 4. So now we'll put positive 1 back into the original equation. And that is 2 to a negative exponent, 2 to the negative 1. And a negative exponent, recall, is reciprocal. So this is 1/2 plus 3, which is 3.5. So the last number we need to put into this original equation is positive 2. And 2 raised to the negative 2 is 1 over 2 squared plus 4. Oh, sorry, I'm talking to myself again. 2 squared is 4. So that's 1 over 4 plus 3, which is 3.25. So if we were to plot these points at negative 2, we're way up there at 7. Pretty much off the paper. At negative 1, we're positive 5. At 0, we're positive 4. At 1, we are 3.5. At 2, we're 3.25. So you can see that this is another decreasing function where we're coming down. And how low do we go? Well, apparently we're going to be leveling off right about here. How do I know that? We are going to be leveling off to positive 3. So that's where our asymptote is for this exponential graph. And make sure on your graphs that you have arrows when they continue to grow and get taller and taller, so I know that they're not just stopping. So for this problem we can talk about the domain and range again. And domain pretty much for all of these exponential graphs is boring since it's always minus infinity, positive infinity. But our range is something a little bit more interesting. How low does this graph go depends on the number added outside of your expression being raised to a power. So it goes down to 3, but it never gets there, so it's a parenthesis, and it goes up forever. But this is also what we call a decreasing function.